Hello everyone. In this video lecture, we are going to discuss about tabulation method and the steps to be followed when we are applying tabulation method to find out a simplified Boolean function. And we will discuss all these steps by considering with an example. Now let us start the class. Now here, this tabulation method is also known as Queen-McCluskey method. Here, as the number of variables are increases in the function, the map method of simplification is not convenient, so that to overcome this disadvantage, tabular method of simplification can be used. Here, the main drawback of the Karnaugh map is that when the number of variables are more than 5 or 6, the Karnaugh map method is very much tough to find out a simplified Boolean function. So to overcome that disadvantage, we are going to use tabular method of simplification. Now we will see the procedure, how we are applying these steps to the Boolean function. Now here, in this, the tabular method of simplification is a specific step-by-step procedure that is guaranteed to produce simplified expression for a function. Now the second point here, firstly we need to list off minterms in the binary code that specify in the function. Then divide the binary codes according to the number of ones. Now coming to the next point here, now compare each minterm with other minterm in two subsequent rows. If the minterms differ in only one variable, that variable is removed and a term with one less literal is found. Coming to the other point, this process is repeated for every minterm until the exhaustive search is completed. And here, the remaining terms and all the terms that did not match during the process comprise the prime implicants. And with this prime implicants, we are writing the simplified Boolean function. Now we will discuss step by step. Firstly, here this tabular method of simplification is going to provide the simplified Boolean function. Now here in this first step, whatever the minterms mentioned in that function, for all those minterms, firstly we need to write the binary codes. And coming to the next point here, whatever the binary codes we found, all those binary codes we need to divide into number of ones in different rows. If it is having 0 number of ones, we need to consider it as in one row. And next, if it is having 1 number of one, for all those minterms, we need to write in another row. And if it is having 2 number of ones, and whatever the minterms are having 2 number of ones means, we need to list in another row. Now we will see that point by considering an example. Next, we need to compare each minterm with other minterm in two subsequent rows. Whatever the rows we are writing, and each row, each minterm we need to compare with each other. So that if we are in this comparison, if we are going to find the one bit difference means, we need to remove that variable and keep a dash mark in that respective place. And we need to write those terms with one less literal. And then we need to repeat this process for every minterm until the exhaustive search is completed. Then finally, after the search, whatever the comparison is not possible minterms, we need to list out it as prime implicants. Now we will discuss the tabulation method procedure steps by considering an example. Here is the example. Simplify the following Boolean function by using tabulation method. And the function is function of wxyz is equal to sum of the mentioned minterms are here 0, 1, 2, 8, 10, 11, 14 and 15. Now in this tabulation method procedure, firstly we need to list out all the mentioned minterms in binary form. So this is the table showing that whatever the minterms present in this function, For all those minterms, these are the binary codes. These binary codes can be written like by using a 4-bit binary code with the weights of 8, 4, 2, 1. Now, by considering all these binary codes, we need to divide these binary codes according to the number of ones in different groups. So, this is the table showing that determination of prime implicants in the simplified Boolean expression. So, if we consider this is the column A, column B and column C. Now, all these binary codes we are going to divide into number of groups according to number of ones. If we see here, this is the 0 minterm and in the 0 minterm there are no ones. So, this is showing that 0 number of ones in first group. And coming to the second group here, M1, M2, M8. For all these minterms, they are having one number of 1. So, we listed in second group. And then M10 minterm, it is having 2 ones. And after that, M11, M14 are having 3 number of ones. And M15 is having 4 number of ones. So, by following this procedure, we need to divide all the minterms according to the number of ones. Now, coming to the next step, here we need to compare each minterm from one row to the second row. So, here we need to compare 0 with 1, next 0 with 2 and next 0 with 8. But here we need to consider only if the comparison is possible. That means if the minterm binary code is differing with only one variable means the comparison is possible. Now we will check it out once. Here when we are comparing M0 and M1 minterm, if we observe only in place of Z variable, the binary bit is differed. So 0 changing as 1, remaining 3 bits are same. So we can write here 0 minterm is compared with 1 and the code is going to be 0, 0, 0 and whatever the variable is differed here, we need to keep a dash. And whatever the minterms we are compared in this comparison, for those minterms we need to keep a tick mark. So then after that we need to go with 0 minterm with 2 minterm. So for this 0 compared with 2, then also we are having a 1 bit difference. Here in place of y variable, the binary bit is differed. So the binary code is going to be 0, 0, dash 0. Now by following this procedure, we need to compare first row minterms with second row minterms with third row, and then after that third row minterms with fourth row, and after that fourth row minterms with fifth row. So all those minterms we need to list in column B. Now these are the possibilities can be observed in this column B by considering second row with third row. These are the combinations can be observed, and then after that third row with fourth row. So these are the binary combinations can be found, and after that fourth row with fifth row. These are the binary combinations have possibility like this. Now when we are comparing each minterm from one row to other row, we need to definitely keep a tick mark here. Now when after finishing this column B, then we need to move to the column C by considering the binary combinations from this is the first row to second row, and after that second row to third row, and then after that third row to fourth row. So in these combinations also we need to differ only in one variable when we are comparing from one minterm to other minterm binary combinations. Now if we observe, we need to compare 0, 1 with 2 and 10. Now if we observe here, the Z variable is having dash here, and in this combination W variable is having dash. So the comparison is not possible in this case. Now then we are to move with 0, 2 minterm binary combination and 8, 10 minterm. Then only here possibility. Here these two binary combinations are having dash in the same place in place of y variable, and they differ only in one variable, like in place of W variable we have 0 here, 1 here, and the remaining code will be same. So the binary code is going to be here dash 0 dash 0. Now following this procedure, we need to find the different combinations in column C. Now when we are comparing each midterm, we need to keep a tick mark like this. If we observe this prime implication table, we are having not tick this binary combination like 0 0 0 dash. This is unchecked binary combination, and here also dash 0 dash 0, and here also dash 0 dash 0. These two binary combinations are also unchecked because the comparison is not possible for the next column. So here these two binary combinations are repeating two times means we need to consider only one time. Here also the binary combinations is considered as two times means we need to consider only one time. So here unchecked midterm binary combinations are like this, and here in the midterms 0 bit are going to represent with complement variable, 1 bit is representing with normal variable. So we can write here 0 means W bar, here also 0 means X bar, here 0 means Y bar. So this is going to be the one prime implicant, and then after that here X bar and Z bar, and here 1 means W and here 1 means Y. So these are the unchecked binary combination midterms, and we can write the simplified Boolean expression will be equal to addition of all these prime implicants. Now this is the procedure we need to follow when we are applying tabulation method for the Boolean functions. Thank you for watching this video.